So let's do an extreme example of altering the distance between pivot and the end such that one end is very short indeed and the other end very long. So let's go back to the seesaw scenario. I've just got it resting on a little rod there just so to keep it in position. But if I now sit on this end and try and make it move, well, let's assume that I can. Let's say somebody sits on this end and then we expect that end to come up. But it's the amount, but where's he gone? It's the amount by which it comes up that's the staggering thing. So a small movement on the shorter end creates a very exaggerated movement, and now straight away we can see where the character on the end could get catapulted out of the playground. So the idea there is you've proved that, well, it's not really a seesaw, but it's starting to sow the seeds for lots of ideas for levers where this would be useful, not in a seesaw, but in something like well, if we just use our imagination for a second here, you've got a very long arm that can reach a long way, and that's sort of how you might sort of regard a fishing rod. So if it had a line on the end, the rod allows you to move but also reach. Well, a fishing rod isn't a very good starting example. A crane is a much better example. So for example, if we had a hook on the far end and then a way of manipulating the shorter end, then we've got a long reach as in a real crane, and we can lift things up. There are lots and lots of examples of how this might be a useful sort of arrangement to have. Very short at one end and long at the other. And of course, a simple crane model might look something like that. So the idea is here, we've got our little crane, the crane's got a hook at the end, and what we can do is lower the crane, so not just lower it down there, and because the string at this end is pulling on the short end of the lever, it can raise the longer end. And because in a crane it's useful to be able to reach, well, the longer end gives you that reach. So there's our little hook on the end. Now the winding action. So now the force is applied at the short end of the lever by the winding action of a string. And of course this would be powered by an engine in a real crane. But we've still got the pivot, we've got the shorter end of the lever, we've got the very long end of the lever, we've added a string so it can behave like a proper crane and hook things up, and we've got a mechanism now to attach to that lever, pull on the string, raise the jib of the crane. So that long lever would be called a jib. Well, another possibility might be something like a siege machine from medieval times or pre-medieval Roman times, for example. So what we've got here is a very, very simple structure which contains a lever, and this time the lever is this long arm and it's pivoted at the very, very bottom. There's nothing at the bottom to grab onto to make the lever move. But what we've got is the pivot position for the lever there. So there's our pivot there, that rod through there. And the force that we apply in this particular case is via an elastic band, which is on the inside. So that elastic band being stretched and then applying a force near the middle of the lever this time still would make the far end move a great distance. So let's just try and find an object of fire. Let's have a look, see if we've got a ping pong ball somewhere. So we've got our little ping pong ball, in it goes. Let's move it right back here. Pull on the lever, the elastic band stretches, and off it goes. So this idea of having the sort of long arm is very, very useful, and there are lots and lots of possible applications. When you think about things like bridges, swing bridges of all different types, the ones that swing vertically up, that's like two cranes working together. So levers are even on a colossal scale, as in bridges.